Alright, streaming begin. Alright. So, I ended up with access to an Elemental server. That would be the server that's at the crux of the Bloomberg discussions. And so I went ahead and grabbed a dump of both the BMC firmware and a BIOS. And I started to take a few notes about what's in those and what their layout is. What I was asked to do was actually to peek inside, see if figure out what version of the BMC firmware I pulled off the machine and be able to see if there's compare that against a known reference source. And I don't really I haven't been able to figure that out quite yet, but I also haven't spent a whole lot of time looking at it. Most of what these notes, which are really small on that screen, aren't they? That's probably a little better. There we go. So most of these notes are really from looking at running binwalk or a similar tool on it and match up with what I would expect. Specifically, these BMC flash parts, typically, BMCs almost always run a Linux system of some form, at least in modern versions. And so you're almost always going to have some sort of bootloader, typically U-boot, but not always. And then a compressed kernel image stored somewhere, as well as both read-only and read-write partitions. So usually a read-only root file system, or a boot, or like an init file system, and then sorry, I'm also setting up a VM over here. Of course, I just shut down the VM that I was starting up. Right, so you almost always have a read-write partition that's used to actually store the configuration data, as well as a lot of read-only sections. And the intent is that this is a device that should boot routinely and not have issues. So they want a fixed image along the way. Alright. So, yeah, a lot of these things aren't particularly surprising. Like I said, you almost always have a small root file system or whatever. And these are just come out of a SPI flash. There's nothing particularly special about them. I will also be watching the YouTube chat if anybody has questions. The main thing that I'm doing right now is trying to get a VM up. When using binwalk, wow, there's some serious lag on that video. I wonder if I can actually improve. No, I don't know what's going on. Oh, I do know what's going on. My bad. Hang on, let me restart the stream here. Okay, hopefully this works better. I dropped the video resolution with the hope that it will keep up bandwidth-wise better. I cannot tell what's going on streaming wise. Interesting. I must be using most of my upstream bandwidth. Okay, well, anyway. So for those who might be unfamiliar, you get to watch me my way through setting up a Ubuntu VM. So hopefully we can walk through a little bit of how I've gotten to where I'm at. So let me jump over to my VM here. And one really important tool to start with is just good old binwalk. So binwalk, as they say, is a firmware analysis tool. It sort of looks for known signatures inside of a file, known magic numbers, those types of things, and if it can, or it kind of tells you offsets of where things are in the file and what they might contain. And of course, being that this is a completely new VM, it has nothing installed. So I am watching the YouTube chat if anybody wants to have questions or wants feedback or anything. I'm doing what I can on terms of the video quality. It looks like I'm pushing about 2 megabytes a second up, which thanks Comcast. Right. So get. Uh-oh, I think I may have gotten popular. What? You ever notice that you have to actually put escape spaces in quotes when you use SCP? I never quite understood that. Okay, so following the instructions as written, simply run. Of course, I have it on 3. What? %90 of computing is setting up your environment. No. That's why people are retweeting the crap out of this. Alright. Well, it's probably going to be boring. So, sorry. Great. So, bin walk. All I'm going to get out of this is, as I said, it looks through the signature of, or 4 magic signatures in the file and just kind of tells you offsets of different things. And the very first thing we find is that it's got a ton of zlib compressed data going on, which doesn't really help that much because what's happening and why there's so much output here is that it actually found a JFFS2 file system, but JFFS2 uses zlib compression internally. So it's actually just really getting confused about JFFS2. Now, there are some additional dependencies that you can install with binwalk. That'll, with the additional dependencies, it's more or less just going to be able to extract some of these sections of the file and do some of the work for us. But I already have played with this a little bit while I was on an airplane, and granted I was on a Mac and it really didn't like me. So it can pull out the JFFS2, but it doesn't give you a coherent file system. It kind of keeps finding different segments of the file system and doing oddball things with it. So if the stream isn't working well for some people, I am also recording this and I'll be posting it up on diode.zone later. That's a PeerTube instance that Micah runs. Scanlime. as people keep joining. So I've done a little preliminary poking at the file, the firmware dump that I have from an Elemental server, and recreating or setting up a VM with all the right tools. I was doing most of the initial work on an airplane with a Mac, and it was not going well. So while we wait for that, just to recap what I know already from playing with binwalk and kind of looking at the file. As expected, BMCs are almost always little ARM Linux machines, and so they kind of have the flash for them has this general structure of having a bootloader that gets you running, have a compressed kernel as a separate entity in there, having a few read-only sections in the flash as file systems, and then having a couple of read-write partitions with various content. And usually this is done so that you can, if you think of the BMC as an embedded system, if you were, when you go to do an update of it, you want to make sure that you don't kill it. And you also want to be able to revert if you have a bad settings change or something like that. So I'm expecting that this whole JFFS2 thing may very well be a single file system, but binwalk has its own interesting challenges with JFFS2 apparently. Bootloader is usually U-boot, but not always. We'll probably be able to play with that in a little bit. Definitely discovered that there are a couple CramFS in there. One of them definitely looks like a web server, and one of them that looks like a root file system. So I came at this, looks like we're getting caught up back over here. So now that we have all the dependencies for binwalk installed, so if I just run binwalk on that BMC bin, right, so we're still seeing that when it goes and runs, when it finds this JFFS2 file system, the binwalk keeps seeing later sections of JFFS2 as well as the actual compressed data inside the file system. It sees a lot of the individual pieces, and so it kind of just creates a mess. But here we see at the very beginning copyright string tucked inside the bootloader. One thing to note, this part, even though there was a lot of speculation and talk about A-speed parts, it actually is a Nuvoton BMC on these. It's one of their older generation, the WPCM 450, which was used a lot on Supermicro and Dell machines. It was a pretty popular part. Internally, its nickname, its code name, which one was this? Erman. And Nuvoton is actually part of WinBond. They're all through the same group. So if you see references to WinBond, it's because at one point in time the part was actually made by WinBond, now Nuvoton. So there's definitely this JFFS2 file system we'll need to poke at. Then all the way down at the bottom there's a couple of CramFS, 2 CramFS and a zip archive containing ostensibly the kernel. So I already went ahead and carved up these into different segments with DD. So just went ahead and calculated the offsets for different segments. So like here's the 2 meg zip file and here's the CramFS. And so if we go ahead and poke at the this, it says it's a zip. let's see what happens if we actually make a visit. Because I don't quite believe that. I mean, I guess they could. Yeah. Yeah, I didn't really expect that to be a zip. Is it a gun zip? Probably not, again. Right, it's just a gzip file. Now we get data. Well, is there anything interesting to start with? So it's not an ELF binary because we would have a 7F at the beginning and the ELF signature. Yeah, I mean that definitely looks like some kernel-related strings there. Right, here's another reference to the WPCM 450, which is the actual Nuvoton part. You know, I wonder if this is not actually the Linux kernel, but if this is actually the raw U-boot. So Nuvoton parts typically, the ROM inside of them is very, very small. So they have oh. Yes, I can turn down the game. Sorry. We don't need any of the talking. So, typically in a Nuvoton part, you would have a very small built-in ROM that is mainly there to load a first stage bootloader off of the SPI flash part, and it would do so. Nuvoton is pretty good about actually having a full signed boot process for that. So it's very likely that the first 256K here is actually their custom bootloader. That is the first stage that does sort of platform initialization. Once the ROM loads the loads this segment, it's going to use this to actually go and decompress this gzipped binary, which is likely a U-boot, which then is used to actually load a kernel from somewhere else. But I am more interested in the CramFS file systems. Well then. IP62. Well, that may actually be a kernel. Tough to say. Definitely not an ELF binary. Alright, but instead let's play with CrimFS. Now, oh, it's been so long. So, yeah, why do I even have that on? Let's just mute the crap out of that. Yes, I can run strings on it. As I said, I'm not particularly interested in the kernel at the moment. So let's go ahead and look at this just to prove we can do it. Okay, so as I said, I've poked at this before, and that's how I knew this already looked like a web server. Now, what's really interesting about this is you see all the different jars that are compressed. This is, if anybody's actually played with a Supermicro BMC, maybe you haven't. Let's do that as an experiment. I happen to have a different one here. Just a second. Set up another scene here. Cool. So I happen to have a Supermicro BMC attached on my network through a different server, but they're similar. So when you log into one of these, you actually get this overview page, and BMCs are actually tied into things like the keyboard interface and the video card and everything else. So I can actually get a preview image from what's on the console currently and crap like that. But over here under console redirection, if I hit this launch console button, I'm actually going to get this jar, which is really a Java Kickstart system, and that's just to run the interactive KVM. We can actually see what happens here. Or it's a web start. Show you what happens. Where did that go? That's what I wanted. There we go. So you end up with this little Java-based KVM, and it does have features like virtual storage and keyboard and all this kind of stuff. These are really the functions that people play with a lot, because while this is a Java applet that actually interesting. My furnace also kicks in a lot with background noises. So here when you've got the virtual storage and virtual keyboard, those are usually the interfaces that people really screw with, because when I do virtual storage, I can actually attach an ISO image as a CD-ROM drive or push a floppy disk image remotely. These are some of the things that make BMC such interesting targets. But going back to our thing over here, so we've got a this overall is literally this same web page. I'm pretty sure I actually have the exact same BMC in a different machine over there. So I doubt. So YUI is usually a build system for building assets for web pages. Page is going to be all the actual different pages that get loaded. Surreal and land, sure, why not? So they're JNLP pages that get served up. Yes, that probably means that it's actually running a Java web server, which is scary and terrible all at once. Lots of JavaScript that gets pulled in. We'll ignore CSS, but there's the various images. And then clearly CGI is going to be some of our more interesting stuff. But these are also going to be just the actual CGI images, or like these are very likely compiled binaries for everything. But as you can see, it is a 32-bit ARM system. And yeah, so there's not a whole lot to poke at right here unless you're looking for vulnerabilities, which is not what I'm actually trying to do right now. I mostly want to know system information. Like I want to know what version of the BMC this actually is. So, knowing that I have another CrimFS over here, so let's just go ahead and rename this one. We know that that is BMC Web Root. Now we have another one that I suspect is actually the root file system. That's 1800. Oops. And what do you know? That certainly looks like a root file system. Now, I want to find something that tells me what the version information is. That is one short Etsy profile. Okay, just because. What do they put in here? Interesting. I mean, it looks like a canned file from somewhere because I can't imagine anyone ever installing MySQL or Postgres on a BMC. Sabian is the only one that actually looks like a interesting thing. So let's look at fstab. Nope, that's not particularly interesting. Not a whole lot service-wise, actually, is there? I'm not seeing anything that tells me... Oh, here we go. So this one BMC, it appears to be used for a crap load of different boards. Also not unsurprising. Now, I'm also working under an assumption that this is actually a AMI Mega Rack product. So in the BMC world, Mega Rack is kind of the go-to solution. Often you buy it when you, like, a lot of people use AMI's Aptio for UEFI for their systems, and so if you're already working with them, then getting Mega Rack is a good solution. And it's a BMC firmware stack that's completely built up and supports all these parts. But one of the things with that is you build it once, and then they have all these different personalization bits that are things like the actual GPIO configurations and the bus configurations, what sensors are available, etc. So that if you're a OEM or ODM making a board, you don't actually have to have the full source code to the to Mega Rack. You get sort of a binary blob and then these personalization files. I'm not sure what happens in Supermicro's case, what their licensing is, but like this looks a lot like what I would expect for the configuration. So this is like, oh, if I'm this particular board, then please install these different types of configurations and that kind of stuff. Again, I'm mostly just trying to figure out what version this is. We didn't power up the board or do anything to look at the reported version, and so it's very hard to know. Interesting. Firmware Rev 9 and 99. That doesn't make any sense. These are what? X9. I have this somewhere. SRW5. So, if those are actually the firmware revision, 339, then I do. Okay, so this must be the latest one. So I had downloaded the latest image from Supermicro, which is this zip file. So the SMT X9 339. And that seems to match what's over here in this data file. So let's go ahead and take a look. What do I call that? Really? Okay, so they end up with SMT X9 339 bin, which is a 16 megabyte image, which my flash dump is also a 16 megabyte image. Will they blend? I'm going to guarantee that they're probably not gonna, that this is not gonna work. Just because I know that they have read-write sections in them. So in terms of doing comparisons, what we'll probably need to do is divide the file up. So a similar thing, I want to split up that file into chunks that align with the original BMC image, so that I can compare the individual file systems. What am I doing? I should not do things when I get sick. Done all these calculations before. I really wish that DD took hex strings as oh, this is that stupid thing where Ubuntu doesn't actually have calculator. It puts a menu item that when you run calculator the first time, it downloads a snap and actually then runs it. Yeah. I might be able to do this because I have notes over here. So if I add skip 7 plus 64. Yeah, I think this is actually 768, and then this starts at an even boundary. Makes more sense. mine has a 128 section. Oops. Then after that 128, so that's what, 152. And just as a cross check here. What? Oh, I missed an order of magnitude there. 9, 8, 1, 2, 3, 4. 9, 7, 28, which, if I subtract 192, should be 1536. Great. I can do math today. Okay, so let's see what happens. Let's do that. Oh, right. Cool. So I should have a 16 meg overall image, a 256K bootloader, 768K of something, 128K of something. Oh, I should have 264 sections. What did I do wrong here? Oh, I used the same file name. There we go. Right, a couple of JFFS chunks that I don't really know what they are. Kernel, rootfs, and webroot. And so if I run on a webroot, I should get that that is a cram. And rootfs should be a cram, and kernel should be, right, gzip. And these should be JFFS. Yep. Okay, so if that's that, then if I do the same split on on the update file, which conveniently is an entire firmware dump. So let's compare the bootloader to the one that I pull off. Not the same. Are any of these the same? Okay, so the root file system is actually the same. And the web root's probably the same. Yeah. Kernel's the same. I don't know why the bootloader isn't the same, and I'm gonna bet that most of these JFFS file systems are not. Kind of the whole point of these is to be different. Yep, they're all going to be different. Okay, so we know that now that the kernel, rootfs, and webroot, which would be the actual runtime things, are all the same as the official update that I downloaded from Supermicro's website for this particular board. Bootloader is different somehow. And the JFFS are different. So I am curious about what's in the JFFS, just to make sure that my guess is actually right. Do I not have a way to... I don't need any special tools for this, do I? Oh, I can't mount it quite that way. Got it. Okay. So the first one has so these are the actual configuration files, which would explain why it's going to be different. I bet the drop there is actually, it generates a key. Or maybe they just loaded a key. Server.pem. Fun things to play with later. Okay, well, that definitely looks like that's interesting. Why did they have two file systems that are different sizes but have mostly the same content? I guess it's possible that this is all one big read-write partition. I'm just seeing sections of it. Or they're doing some sort of overlay file system. Oh my. So I can attach authentication of my BMC to an Active Directory server? I really hope that's not true. Okay. So that definitely looks like a more like the first JFFS file system looks like maybe a reference version as a fallback, like we're done at update time, and then the second one really appears to have a heck of a lot more in it. Yeah, I'm wondering if that's just one big JFFS file system. It's an odd size. If is, going from my notes, 11:52. Oh no, I'm gonna add another 128 to that. Just doesn't divide nicely. It seems really odd, size-wise. Yeah, that looks a lot more sane. It's just one big file system with all the mutable state on it. So they really just run a yeah, the kernel, the root file system, and the web root are all fixed. There's I bet the bootloader has an environment block in it. So U-boot and other bootloaders often carve off a space inside of the flash as a place to store environment variables. And so like the tail end of that segment that I'm calling bootloader might actually be that worm. Yeah. Though 256 is kind of a clean size for a bootloader too. They may have mixed and matched. What is checksum info? Oh. I bet that they overlay a JFFS2 partition on top of a directory inside of the root file system. So, right, that would make sense. So these would only be the modified blocks, or at least the modified files. But there's nothing revealing here. Why is this? I got some wonky permissions going on. Well, let's see. I don't know if there's a way to actually get a second I can request another MTE device. Yeah. So they start with a blank JFFS partition, and then they do an overlay of it. So because the CramFS is actually a read-only system, so everything that's listed here are actually files that were changed in the root file system somehow. Likely in like Etsy or something. And there doesn't appear to be anything particularly nefarious in there. If you're wondering about some of these block things, FRU is field replaceable unit. These are it's a common term for a device that you can replace independently. But there's also a specification for fru storage, which is a way of using an EEPROM to encode things like the part number and serial number. So there's a standardized format for this. If you're ever pulling apart a server, somewhere there will be this data. So the fru block here is really just that information. The cell block, again, IPMI has a system event log. So the cell block is actually just they're carving, basically instead of putting actual EEPROMs on boards anymore, the BMC acts as a I2C or SPI EEPROM. And so the cell block is that. Firmware block, I'm not exactly sure what that is. It doesn't appear to be the BIOS. But it could be firmware for something else. Yeah. Well, I mean, this mostly answers the question that I was asked to look into, which was, does this appear to have been tampered with in any way? And at least on the BMC side, no. I guess we didn't look too closely at the bootloader section. I mean, I know people have done a lot of work in the past on actually doing threat analysis on these things or scrutinizing the build environment or the actual OS environment. And we could certainly go into that. I'm sure there's, I mean, look, this is a web server that renders JNLP pages and has binaries for CGI scripts. So it's kind of fertile territory. Any one of those CGIs is probably got a problem. Just saying. So if you want to play with that kind of stuff, go grab any BMC image, and you're likely to find the same kind of thing of the layouts of file systems with CramFS and JFS2 overlays. And sometimes you'll have A and B partitions. It was something that we talked about doing for OpenBMC, which is actually how I got a lot of the information that I have here. Is OpenBMC has internally a bunch of, or it is a suitable replacement, but mainly currently mostly developed for open compute platforms. But you can actually go look at exactly how the file system layouts happen and a lot of these different device controls in a much more sane environment. So I wanted to, let's see, XXB has an option for this that I want. There's a way to get it to do portable style, I thought. There's a special option. No, alright. Any requests for things to poke at? Any particular questions about BMCs, their firmware, etc.? Wow, that's a very small diff between those. Yeah, that looks like a storage page. Where, yeah, that's just gotta be like environment storage. They need somewhere to write things like a boot counter and things like that. It was all F's in the initial file. It got written a couple of bytes here and there. It's non-volatile storage. So yeah, nothing particularly special. Well, no questions have popped up in the chat, so I'm gonna call it for this. Thanks for watching.